of linear equations. Oh, sure. There you go.
Thank you.
You're welcome.
What was the first one?
Oh, for
The book, yeah, I read it. Did it involve the symbol?
So now we're going to go over the definition of a system of linear equations. And it's just when you have two or more lines on the same graph. Okay, a system of linear equations. Two or more linear equations on the same graph. Okay, so normally you can plug in an x value and y value and say, okay, if it appears on the line, it's a possible solution. With a system, it not only has to plug them in and appear as a solution for one, it has to appear as a solution for both of them. So a solution of two equations is an ordered pair that is true for both of them. Uh-oh. Why did I put a P there and I meant to put it? That is a solution. Oh, bring that up a little. To both equations. Okay, so let's say, for example, let's say if we wanted to determine if the ordered pair 12 and 6 is a solution for the system. Okay, so we're going to get both of our equations. So you have 2x minus 3y equals 6, and x equals 2y. Well, that's supposed to be a bracket, but I have a tendency to draw my brackets a little bit messy when I do it too fast, so it should kind of look like that. Okay. So that's when you have both of those equations appearing on the same line. I mean the same graph. Okay. Now to find out if it's a solution, we just plug in our x value and our y value and see if both of them end up being true. Let me see. For our 12 and 6, that means our x is equal to 12 and our y is equal to 6. To see if both are true. Okay. So if we plug it into the first one, so we have 2x minus 3y equals 6. So if we plug in our x equals 12 and y equals 6, that's 2 times 12 minus 3 times 6 equals 6. Okay, so all we did was replace our x with 12 and y with 6. So that gives us 24 minus 18 equals 6. Bless you.
Thank you.
24 minus 18 is 6. So we end up with 6 equals 6, which is true. Okay, so it's true for one. Now we just plug it into the other one and see if it's true. Okay, so we have x equals 2y. So if we plug in x equals 12, so 12 equals 2 times 6. Well, we end up with 12 equals 6 times 2, which is 12. So this is true. So since we plugged it in and it was true for both of them, we actually know it's a solution. Well, instead of putting this, put the actual value. So we know that 12/6 is a solution. Move that up some. To the system, since it is true for both. All right, any questions on that one? All right, I'll leave that up for a few more seconds. Alright, so let's say if we have say if we wanted to determine if -1, 2 is a solution to the system in this system, let's say the first is x plus 2y equals 3. And the next is 4x minus y equals 6. So for this one, we do the same thing. You have your -1, 2. And your x is equal to -1. And your y is equal to 2. And you just plug them in. X equals -1 and y equals 2. Okay, so if we have x plus 2y equals 3, if we plug them in, we have -1 plus 2 times 2 equals 3. So you have -1 plus 4 equals 3. Or you end up with 3 equals 3, which is true. Okay, so it's true for the first one. Now we just plug it in and see if it's true for the second one. Okay, Okay, so you have 4x minus y equals 6. Okay, so we have 4 times negative 1 minus 2 equals 6. Okay, so you have negative 4 minus 2 equals 6. But if we simplify that left side, we have negative 6 equals 6, which in this case is false. Okay. So unless it's true for both of them, it's not a solution to the system. So in this case, it's not a solution. Oh, bring that up. All right, so any questions on that one? All right, leave that up for a few more seconds. All right, so let's say, for example, determine if, say, negative 4, negative 2 is a solution to the system. Okay, so let's say 8x plus 5y equals 4. And let's say y equals negative 2x over 3 minus 5. Okay, so just like before, we just plug in our x and y values and see if it works for both of them. Okay, so if we have our negative 4 and negative 2, that just means that our x is equal to negative 4 and our y is equal to negative 2. So go ahead and plug it into the first one. So we have 8x plus 5y equals 4. That means if we go ahead and plug them in, that's 8 times negative 4 plus 5 times negative 2 equals 4. Equals 4. Okay, so we have 8 times negative 4, which is negative 32. 5 times negative 2 is negative 10, equals 4. Okay, so we have negative 42 equals 4, which is false. To be honest, as soon as one of them false, you don't even have to worry about doing the other one, because both of them have to be true in order for it to be a solution. So as soon as you find one false, you're done. All right, any questions on that one? All right. Okay, so no need to solve the other equation, since the first try was false. So we know it's not a solution. All right, leave that up for few more seconds. I'm still writing. Looks like everyone's done writing. Okay, so what we wanted to know is, does the ordered pair so if we have 2/3 and 5/6 satisfy the system, and for that system we're going to have negative 8x minus 10y equals 3, and 6x minus 6y equals 0.